the ATAL FDP program on generative AI techniques, tools, and application. In this rapidly evolving world of AI, generative AI stands at the forefront of innovation, transforming the way we create, analyze, and interact with technology. I extend my sincere gratitude to all the participants, faculty member, and research professional who have joined us today. A special welcome to our esteemed speaker, Dr. Dushyant Kumar Singh and Mr. Divyesh Dixit, who will be enlightening us with their expertise in this fascinating domain. Dr. Dushyant Kumar is our first speaker for today's session, who will be presenting on the topic of towards a generative model. It is our privilege to have with us Dr. Dushyant Kumar Singh. He is an associate professor in the Department of Computer Science and Engineering at MNNIT Allahabad. He has more than 15 years of teaching and research experience. Of his area of research interest are computer vision, image processing, embedded design, and high performance computing. He is working towards developing intelligent solution for vision-based problem. In his in his career, he has published more than 100 research papers in reputed journal and conference proceedings. He had delivered a good number of invited talks at many reputed institutions. He is he is a member of ACM and a senior member of IEEE. He has received a good number of grants from DST Sub and executing research projects. He has He has 4 patents granted in his name. He has been the past chairman of CSI Allahabad chapter and present vice chairman of IEEE Computer Society, IEEE Up section, who has significantly contributed to the field of AI and its application. Their knowledge and experience in generative AI will surely provide us with deep insight and practical understanding of this emerging technology. Before we begin, I would like to remind you all that if you have any question during the talk, feel free to drop the message in the chat box and we'll address them during the question answer session at the end. Let us welcome together Dr. Dushyant Kumar Singh with a huge virtual applause. Over to you, sir. Hello.
Oh,
Hello,
sorry. I
Dr.
was muted.
Dushyant.
Yeah. I think now I'm audible. Is that?
Yes, sir, you are audible.
So, thank you very much for such a nice introduction. And good evening to one and all present here. So, all those attendees and the coordinator teams. So, I think now it's a high time to actually start on. So, since the time is obviously a limited one, so 1.5 hour time hopes not to be enough time for means delivering such good things and for means elaborative understanding. But anyway, we will try to actually cover it up in this given time. So let me then present my uh, presentation, how to actually just share here from here. So please tell me whether my presentation is visible to you all.
Yes, sir, it's visible.
I send the full slideshow mode actually, and please also acknowledge me whether means I'm trying to actually change the slide, whether is this change in the slide is visible or not. So I'm doing this slide change. Is this visible?
No, sir, slide change is not visible. I can see only the front
All
first
right,
slide
all
of
right,
your
all right, all
presentation.
right, all right. So this actually happens, generally happens. So I do actually check at the start itself.
Yes, sir,
So
now
what
it's
I'll do
moving.
now, it's moving. So
But you. to stop sharing the screen.
hold on. So what I'll do is I'll share my entire screen itself,
Okay, sir.
and now it's here. So I think now this change in the slide might be visible. Is that
Yes, sir. Yes, sir. It's visible now.
all right? All right. So this is what the topic means. I find it best to actually talk upon an thematic area of this FDP that is revolving around generative AI and all. So means how things has actually moved up to the generative modeling. So means when we say the time when we was actually knowing about a single term like AI, and then we had seen the coinage of so many terms in line in the history, like going from
Excuse me, sir. Sorry to interrupt you, sir. Can you share your full screen?
it's the full screen itself.
Okay. Okay, fine. Then continue.
All right. So so that is how means it means from there to the coinage of many more terms like means then we heard of uh, means expert systems, then terms like learning machines and machine learning, then deeper further into the terminologies like deep learning, and then another dimension of the deep learning has been explored, like means we are talking now is generative space, generative modeling. So how it has actually gone, or what was the pathway actually which has been traced from starting of AI and till this generative modeling, and what further are happening in this world. So we will have a glimpse of it, and certainly I'll go in a bit faster mode. So I have a hues of the content in my slides. So I'll take up a pace to cover up all those, and certainly uh, in last of my 30 minutes or somewhere that and the last part I will be actually giving you a good example of means how can we create a GAN, or starting with a simple GAN. Let's say we want to create, so how can we move up? So that's an example there. So exactly means to start with. So this kind of picture everyone might have undergone, means have viewed this. So what it is telling is about the timeline of these different terminologies actually which came up. So the very first thing was means we seen in 50s somewhere was artificial intelligence. So actually this whole story starts from this term itself, the artificial intelligence. And the region was means we come up to the scene that means human being which were actually having some intelligence, and that intelligence level was actually means good enough to do so many things. And then we say that then we want to make our lives simple and flexible. So then we want to actually equip our machines to do so many things for us. So then means the idea was to actually create intelligence artificially for those machines exactly. And then certainly those machines could have done some work for us. That was the actual aim. So in line to that, we had seen so many terminologies like machine learning and then deep learning and so on, and now we are actually, as our talk is all about the GAN or the generative modeling. So we have terms like this. So let's means if you want to understand this pathway or this journey, so let's actually start from the very first term itself. So when we say artificial intelligence, so then we have to actually understand what this artificial intelligence means. And certainly in order to understand that, it is well to understand intelligence first. So what is this intelligence? And we all know means a very humanistic kind of definition for intelligence could be like means intelligence is the ability to solve something, to adapt to an environment, to formulate something. Means that is what the intelligence is. Means having intelligence, one can do these things, one can work out these things. So it's like ability exactly. Now the thing is means where this intelligence, where this ability is gained. So this is gained in the brain. And now the thing is, now there will be a question mark here. So means it's gained in brain, and when we know means that this ability, we have very different measures and the matrix to actually measure it. Means if someone is intelligent, to what level it is intelligent, we have the matrices like IQ, EQ, and so on. The question will then arise as means if it is gained in the brain, then how is that done? Then we come up with the understanding of so many texts like me, so that we get intelligence through experiences. That is what the thing. And now the question will be experiences. So what are the sources of experiences? Then we will see that the sources of experiences are our senses. Now if we try to see in case of human being, so how does human gains the intelligence? So it is through some senses and sources, experience, and the sources are the senses. And typically we know about these five senses. So all of the intelligence is actually revolving around anything you get out of these five senses. And certainly then we can see, if we are talking of artificial intelligence, all of that artificial intelligence can then be actually substituted in these five domains of the senses. So anything means, let's say we develop in the vision domain, so it's the intelligence for that side. It's we call it the vision in for the machine. So the computer, like computer vision domain is there. And certainly we can think of any sort of intelligence being created in these five different domains of the senses. And now the question will be whole this process of gaining intelligence through experiences and having these senses as the source, that this whole process is actually termed as learning. And that is what from there we had coined a term for creating artificial intelligence for machine, is the process called as machine learning. So what happens in machine learning? So or how can we further divide? So many persons had given their own definitions. Like means the Herbert Simmons says that means machine learning is process to improve performance through experiences. Now maybe this definition actually generalizes the intelligence up to a very high degree, but certainly one can't achieve that high degree of intelligence. Means an intelligence in every context, that can't be possible. So another definition by Tom Mitchell is like that means, so so what we are doing is we are actually learning the machine to improve its performance, certainly from the experiences, but actually for an specific context, a specific task. So as in case of human being, none of the human being can't be uh, means ace of every trades. So it's like that. So similarly means when we are talking of we are training machine, we are learning our machine, so it can be actually trained for some specific task. And that is how we actually define it. So through a three tuple like P, T, and E. P is we are improving the performance through what experiences on a specific task. That is what the thing about machine learning. Now, again, a good thing to actually explain here. I generally feel it good to actually discuss this kind of thing. So, when do we use machine learning, or when shall we use we use machine learning? So, it's not a game of the thoughts like means machine learning shall be adopted everywhere. Exactly not. So, where and when? So, I find these four very good facts. Like means one of that is means we can use machine learning, let's say when we don't have expertise, human doesn't have the expertise. Good example is like navigating on Mars. So yes, it's a well and good example. So suppose we haven't visited there, we doesn't have any knowledge of it, but let's say it has to be done. So how can then be done? So certainly some sort of learning, machine learning can be adopted like there. So let's say we send a rover there. So how that rover can will actually be navigating that space? So that is means some machine learning, and we know that what is that is a reinforcement. So some reinforcement kind of mechanism can be adopted, learning mechanism can be adopted to actually then means navigate on means the Mars, or means you can then actually go for understanding the things where we don't have the expertise. then the thing is, suppose we have the expertise but it's not explainable, so then that is another thing. So then we can adopt machine learning to actually explain things. Think. So speech recognition is one. Let's say means I know him English, you know English. Let's say there is third person who doesn't know English. So if I that person is an is audience, then how can I actually means make that person learn? If I'm actually my communication, vocal communication language is English, and he is not able to understand that. So we can put some sort of machine learning models like transformers, which can actually transform my inputs to his transform domain to understand my views. Then the third thing is means can be used for means when we are looking for more customized things. So models must be customized. So the good example is personalized medicine. Certainly. So let's say there are 100% having fever. So it doesn't mean that means every of those 100 uh, means shall be prescribed the same kind of drug. So and certainly it even don't works. That's the human anatomy. So what we go for is personal medicine. So if the things has to be more customized, then we can go for machine learning. And the third thing is when the data is very huge and enormous. So it is actually good means by manual analysis, it's better to actually use some sort of machine learning for it. And if I say so, as I said, that means it's not always good to use and everywhere good to use the machine learning. Is like that. Let's say we want the calculating the payroll, so it's anyway not good to actually use machine learning for calculating the payroll. Like, so one of the good example is given here. So let's say these are the numerals written here in different scripts. Let's say we want to check that numeral 2. So the numerals written here in different scripts in that block, green block. So it shows that these are all numerals which corresponds to a letter or numeral 2. Right? So now exactly there can be many of those which actually I can't have a correspondence. It will be a 2. Okay. So what can and if you go for a false positive kind of cases, like there are other which actually I I find it that they might be two, but exactly they are not two. Okay. So if this is the thing, certainly means we can actually use some sort of machine learning algorithm and we can train it for these different kind of samples, and then that learned model can do job for us. Okay, for doing this kind of classification kind of things. Now, in general, or more comprehensively, if we try to see what could be means if we try to see all kind of problems all around us, means if we try to categorize them and see means what are those problems and how can they be categorized where we can actually utilize machine learning for. So one set of problem could be like recognizing patterns. So it's like means we already have done some sort of these things, like means facial face detection, facial identities identification, expression identification, mean identifying the handwritten text or spoken words, or we have some recognizing patterns in medical images like that. So there are some pattern we want to identify them. So there are means, so this is one category of the problem. And the another category of the problem we generally you maybe is we have where we use machine learning to tackle actually are recognizing anomalies. So it's like this means, so it's a different way of seeing something. So it's so a good example could be like this. Let's say I'm talking of activity detection or identification. So there could be set of activities. So I can train my model for these set of activities. So normal activities or somewhat like that. But when now supposedly I have another kind of activity, like means shoplifting, detecting shoplifting kind of events. So one of our student PhD thesis was on that. So I can well correlated with that. So so when I say shoplifting, so one of the way out is I can actually model as it is with a shoplifting data. Another way I can have is like when I'm talking of shoplifting in a, a store environment. So what I can do is I can look on a model which actually does the modeling of normal activities, and shoplifting is not usually happening every time. So that's not a usual activity. So I can then treat it as an unusual activity, and my model is actually trained on the usual activities, the normal activities only. Then that can actually give me the unusual activity also. So it's a different way to see the problem and solved by the same methods of the machine learning. So recognizing anomalies like unusual card transactions or unusual patterns somewhere. Okay. Then the another category of problems is like means predicting something. So in the previous ones, so what we were having, so we were actually recognizing something means we were finding out the output, but the output was categorical in nature. But when we say prediction, so prediction means the output is more continuous in nature, means predicting something. So output value could be any. Okay? It is not a fixed set from the deterministic values. Okay? It could be any value. So future stock prices prediction, or it can be like weather prediction, or it could be like energy usage prediction. So that the output can be any value. It could be any continuous value exactly. So that is a category of prediction problems. And the last one is, which is very new to our means uh, this I mean this technology time actually. So this is all about generating something. So generating something means means the things which are actually not existing, and we want to generate that. It's like this means let's say we haven't seen a person or any object of a type, but so it is like a thought. Okay. So generating anything which is not existing. So that's like a generating patterns, kind of generating problems. Okay. There are so many examples of it, like means let's say I don't have means pictures queue of mine of my earlier means age. So what can I do? So means I can think of actually generating those images even by having a model developed for that. Or another examples could be like this. Let's say means we have some monochrome images, and let's say we, in order to well understand them, we do colorize them. So what is that? It's again generating colors in a monochrome. So it's a generative modeling kind of problem. So well means correspond with let's say we have the satellite images. We generally get satellite images in monochrome format. So then when it comes to us, then they are actually manipulated for coloring them, and then it's then easy to understand by having more color coded information. All right. So this is a kind of or set of problem which actually we will be looking here in this theme of our talk. Okay. So this is the space of generative modeling, and aside this, all those previous one were the discriminative modeling kind of the problems, and certainly we have to have a different approaches to solve them. Right. So we'll start with this discriminative modeling, and then we'll come up to the generative modeling. So so what we have in case of generative model, so what we are trying is we have the input x, and we are trying to actually estimate y. So what we are trying to estimate is probability of y given x. That is what we are trying to estimate. While in case of, so if we have the discriminative model, can we estimate p of x? Certainly not. Can we sample any x? Exactly not with a discriminative model. So then how can that be done? So then we have these generative model to solve this issue. Certainly we will at the end of means in line of this my presentation, we will be moving towards the generative modeling kind of a space, but I'll go in a stepwise manner. So let's say we were in line to that, means understanding that artificial intelligence and the descriptive modeling. So very first kind of the kind of modeling we had seen is machine learning models. So how does the machine learning works? So we many of us are, almost all of us might be knowing about it. So we have good number of machine learning models, algorithms nowadays. So how does it work? So as we had already discussed, that means so these models learn through experiences. So what we have to provide is the experiences. So experiences in terms of what? So there will be some X and there will be some Y. So some text documents or images or sounds or somewhat like this. So this is X and there will be a Y corresponding to it. It is the labels. So or you can say a question means with an answer. So that is an X with a Y. So we fed that all these experiences, complete experiences to the machine learning, and certainly the model gets trained with all those set of experiences, huge set of experiences, and certainly we get a predictive model out of it. And certainly then we can use it in the testing phase by giving an uh, anonymous input or means a novel input, which can then you can predict a class of it or means a expected level of it, or in case of regression it means you can predict a output value of it, continuous value of it. So that is what the thing. Now one more important thing which I can see here in this whole image is about this features. So actually when you're saying we are inputting the experiences or we are giving the input, so is the raw input going into the machine learning? So exactly not. Let's say we give the raw input, we know that the model learn will not be that efficient enough. Okay, so what we try to do is, so it's like this. What we try to input to the machine learning model is the very important characteristics or very discriminative characteristic of the input domain. So exactly we are not providing the raw input, rather more discriminative characteristics, and these when encoded are called as features. So these features are nothing but encoded discriminative characteristics of the object classes. That is what the thing. A good example can be seen like this. So this is for spam classification. So spam, an email is spam or it's a benign email. So what you do is you have a set of such emails and what you give as an input. So you do not give whole of the email or every sort of information available in the email as an input. So better is you actually do the feature engineering above it. So what you do, you actually generate or create the features out of the email. So what could be the better feature? So the metadata again in the email, like that. So who is the sender? Is there any link suspicious in it, or is there anything like that? So that is what these are the important things which actually discriminate a spam mail from a benign mail. So certainly, instead of giving a raw input, we will be actually giving that processed features. So and then so in the training phase, we will be training it with huge samples of the spam class emails and the non-spam class emails. Certainly, once it is trained, then we can actually check it by giving a novel email, and certainly it will be categorizing that. So certainly, when we talk of this these discriminative models, so actually they are made to solve out or work out two different kind of problems. So one set of the problem is called as a classification problem, another set of the problem is called as a regression problem or the predictive problems. So in classification what we have, so the only difference is the difference in, so we have the complete experiences to be given to a model in case of these problems. So complete experience means X comma Y. So Y has to be there with X. So when you do the training of the machine learning models in case of these kind of the problems. Now the difference in these two kind of problem is, so X is common, X remains same for these both type of the problem, while Y actually is different. So when your Y is categorical in nature, you say your problem is a classification problem, and the function you utilize to actually do the discrimination is called as the classifier. While in predictive problems, when your Y is continuous, so that kind of problem is the predictive problems or the regression problems, and your then fx is a regressor, actually regressor function. We can see a good examples of it like this. So we can understand with these examples. So first is the case of the classification. So what we do, we have the samples of some object classes like cat and dog. What we have to do is we have to classify me those samples. Okay. So what we have to do is we have to put a boundary on this distribution. So one side it is cat class, another side it is the dog class. Now what will be the input here? So cat and dog is what? Cat and dog is an output label. This is y, and cat and dog are the attribute values of the output y. Okay. So output is a scalar output, and these are the attribute to attribute values. Where in case of input, so input is your x. So what is x? Now here x is not a scalar value. X is here a vector. Vector of what? Two important characteristics or two important features like weight and height. So x is a vector means it will a vector of two values like x1, x2. So x1 is weight, x2 is height, and certainly we can use this kind of data to develop a model. Now, in case of regression, what we have the sample. Now, what we have to do is, so XY sample, Y is continuous in nature. Now, in the test case, what we will be so these samples are to be actually uh, best fitted. We want to actually approximate a function for these samples, okay, which actually covers all these samples. Okay. So this is what the regression is. So what we want to do is we want to approximate a function which actually covers all samples lying on the distribution. So this is what the regression is or approximation is. So how can we do that? What kind of function could that be? It could be a linear function, or it could be a non-linear function also. Okay. So as and when means you want to actually means if you go for a linear function, so it will be a very simplistic kind of a function, but it will be means it will not it will be having a good amount of error in it. Okay. So what will be error here? So error means we use the means squared mean kind of error, mean square kind of error. So error, so why we take a square error? So it is actually at one side it is positive error, another side it is negative error from the means predicted value minus the actual value. So if you do means sum of the error, direct sum of the error, so that could get cancelled out, and certainly it might show that your function is not good in approximation, but your error is zero. So better is to have an error function like this, square of the error. So there could be so many examples of these classification algorithms, and the regression algorithms. Good of these are like this. So classification, you have rule-based classifiers. Like that means predictive logic can be used for rule-based classification. Then you can have the probabilistic kind of classifier like naive-based, and then we can have more instance-based classifier like k nearest neighbor. So they works on voting kind of mechanism. Then we can have more numerical kind of functions like support vector machines, decision trees, random forest kind of thing. Other side, if we talk of regression, so we have linear regression, polynomial regression are there. So it's not non-linear kind of thing. We can have Bayesian linear regression. So we add some probability to those linear functions. Then we can have quantile regression. We can have logistic regression kind of things. So 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 we can have, now we have so many numbers of those machine learning algorithms, and can be used looking in different problems, looking over the feature space of those the problems. Then one of other which is more peculiarly used is we know all about is the neural network. So how and the popularity of them. So we will now actually be pushing up in that direction. So neural networks. So how these neural networks are used. So exactly what the transformations we had seen in the history of this neural network. So it goes like this. So neural network, we all know about it. So we know that these models are actually developed by for mimicking the human brain kind of things, anatomy. So how does a human brain work? So certainly means same kind of anatomy is actually exploited here uh, to develop a learning approach. Okay. So this we know it. So a typical single neural network does look like this. So we have a single neuron structure like this. What it takes is it takes some inputs, and certainly what is done is at the neuron we do take the weighted sum of all those inputs, and then we actually apply a activation function. So and means so this activation this f is uh, a function applied on this weighted sum is v actually, and we get an output out of this activation function. So whether this neuron will be activated on a set of input, so this is relied on this activation function, or means this neuron should respond or react on this kind of input, and how it shall react. So this function decide this. So this is also called as a perceptron. So these are the basic things everyone knows it. If anyone want to stop me, you can stop me and put a question. Now the important thing is how to train a neural network. So there's the basic fundamental of it. So what you do is, so what when we say training, so what does the training in a network means? So it is means, so these weights here, so input is coming from your experiences. These x is coming from the input. So these are known to you. What is actually unknown or to be adjusted as these weights. Okay. So what we have to do is we have to actually adjust the weights and the bias. Bias actually we do fix, and generally we do take, yes, uh, the negative bias are approach for. There are regions, many of you might be knowing it. If even I can tell you later on. So weights. So actually adjusting these weights so that the y we get here is so is actually very much nearer to the expected y. So this actual y we get after this calculation or applying this function, the y which we are getting should actually reach very nearer to the actual y, which corresponding to this input x. That is what is expected, and we actually modulate this w based on the difference we get. So this is all called as a training. So so what we do is, so that's a simple thing. We actually having a random w in very first iteration, we compute the output, we check for the output is actually the desired output is achieved or not. If not, so then we adjust the weights. How we adjust the weights? So this is actually the formulation. So weights, so the previous weight with some is added with some delta w, you get a new W actually, weight, updated weight. Now, what is this delta W? And what are the method to actually get this delta W? So as I had shown here, this delta W seems to be this D minus Y dot X, and further multiplied by this new. Okay. So this is giving us this delta W. So means your W is updated with that value. So what is the basis behind this? So actually what we are trying to do is the error we get, uh, so what we are trying to do is we are trying to reduce or minimize this error. So what is the error? So as we had already seen, we do not take a we do not take error as simple d minus y. So for many different instances, this d minus y sometimes can be negative and positive. So the best of the error function is the square of it. So so d minus y square is the error function, and we have to actually reduce the error, minimize that error. So for minimizing a function, what we do is we actually do the differential of it. So this is what the thing we do. So d minus y square is your error function. So in order to minimize error, so we actually do differentiate it with respect to w. Why with respect to w? Since we are actually calculating, we want to calculate delta w at every w instance. So that is why we are differentiating with respect to w. So what we get is somewhat like this. Differential, you all know this. So del by del w of d minus y square is like this, uh, 2d minus y, and this del by del w of d minus y. So you then you differentiate this del d by del w and del y by del w. So it del d by del w. So d is constant actually. So this was your uh, actual output. So actual always remains constant. So this value will go out to 0, and what you will have is minus of del y by del w, and y is what? Wi xi is a weighted sum. So once you differentiate it with respect to w, it comes to be xi. So this is d minus y xi. That is what we had taken as the delta w function, and we multiply it by with the nu is your learning rate in order to actually do means speed up your learning or slow up your learning. Now that was in case when your function activation function at the neuron was a threshold function or a staff function. But in case when this function is your sigmoid function, suppose your activation is function is sigmoid, then what will happen? Then what will be your this delta w? So in case means here this is your means weighted sum. When you apply a sigmoid function, that is sigma x, so sigma x is nothing by 1 is 1 by 1 plus e minus x. So your output will actually be coming like this, sigma of net. So this is wixi. So this will be nothing but 1 by 1 plus e minus this net wixi. Okay. Now what we have to do is, now we have to actually instead of wixi we had seen here, this term wixi sigma of y. So we have to replace this y with instead of wixi it has to come as sigma wixi in case of this. So here when y is instead of wixi it is sigma wixi, that is sigmoid. So what will this delta wi will become? So we can take it from the previous expression. So it will be d minus y minus del by del w of sigma wixi. So and how do we differentiate the sigma function? So we have here, so differential of the sigmoid x with respect to x is, so sigma x dot 1 minus sigma x. So meaning that here this expression means differential of sigma will be what? It will come out to be wixi dot 1 minus wixi, and the remaining term was xi. So then it will come out to minus d minus y dot 1 minus y dot xi. So that will be your loss function or del w in case of uh, your sigmoid function. Now, so there could be many different kind of the activation function we can think of. So it could be like threshold function or a sigmoid active. Why do we actually go for a sigmoid activation function? So in case of an threshold or a staff function, what means your output could be any value. Now, if we want to actually get the probability of the output class, means the sample to belong it to any of these class. So meaning that we are transforming the output y into a range of 0 and 1. So this sigmoid function does this. So it actually transforms this output to this range 0 and 1. So we use sigmoid for this. Now there could be then some merits and demerits of each of these functions. So what happens in case when we actually use sigmoid? So with very small z, this sigma z comes out to be 0, and what it results is in is it result in killing. It means, so we can from the graph itself see. So actually what happens is output actually saturates. Okay, and what does it show? That means you can't get a gradient here in the error function with this kind of a activation function. So you actually kill the gradient, and this actually creates problem in minimizing the error, and that where it creates the problem. So how can that be reduced? So then that is reduced means we have the 10h functions also. However, there in 10h also we have the saturation. So then that is resolved with a ReLU kind of function. So these are what rectilinear units. So what is good with these ReLU is, it's not complex, since sigmoid was very complex to calculate. These are so easier, means they means less expensive operation. But the another important thing is, it is means you can find the gradient at any place here. So the gradient vanishing problem is also resolved here. But the problem here comes is, so this, what is this ReLU function? It is the max of 0 comma z. So any output less than 0 comes out to 0. So this is what the thing. And once you do this, what happens is your neuron get killed, meaning that it gets inactive and it do not participate in the training. So that is actually a problem with this kind of a activation function. So in order to resolve this function, what is done is resolve this issue. This there is a leak, a small leak is provided, and new activation function is called as a leaky relu. So now it actually turns out to be max of 0.1 z comma z. So there no case will arise of zero output, means you will have every time every neuron participating in the training, and certainly that will resolve the issue of that dead neurons. So there happens to be so many activations and so many thought process to actually how to train a network, and what are the key things where we shall actually focus upon. So we also focus upon features, so how better feature we can create and actually we to train a network. Okay, overall everything we do, then at the end of the day many of us might have come up with these kind of issues, like means your model is actually either underfit or overfit. So what happens, what does it mean actually when your model is underfit or overfit? So your model is underfit means that so this is a situation, this is in case of classification problem. So your model is not able to actually classify all the sample, that is underfitting. So what you try to do is you actually, so this is because of your data is small. Okay, what you try to do, or you increase the number of iteration, okay, to train the same network, so with the same data. So then you it goes for the appropriate fitting, and certainly you don't want to leave any sample misclassified. So you further do iterate it, and certainly with a small size of network and a small data, the situation might come of overfitting. And this is uh, and this problem is very serious. This problem is a cramming kind of a problem, memorization kind of a problem. So what happens is, probably in this overfitting situation your training accuracy might be very high, but your testing sample or the testing accuracy might go down. Exactly, this is example in case of regression problem, same underfitting and overfitting kind of situation. So this is actual the true function, while we train it for another means iteration, so that was overfitting situation. So with less data, less iteration, it was underfitting situation, and then this we come up with a more appropriate fitting. So with low bias and low variance. So that's the thing. So typically the region can be like this when we say underfitting. So it could be like your model is small and your training data is small, so we get low accuracy. Overfitting the situation could be your you have a small model but you have enough data and you do iterate it multiple times like that. So that could be the region of the memorization or the overfitting. Now, the issue till here was means we were having that MLP, means multi-layer perceptron, means the network with lesser number of hidden layers. Your model was a small size model, and you were finding these kind of issues. Then we find that case if we want to improve. So we know that means if we want to resolve the issues of underfit, we want a large data. Now, if you have larger data, you have a smaller model, certainly it will come up to a situation of memorization. So the best idea is actually do elongate your model. So do so, and that is the time and where we had seen the coming up with the idea of deep networks. So do actually make your network more deeper. Once your network is deeper, you have means instead of a smaller means lesser number of parameter to be trained, now you have huge number of parameters to be trained. So number of parameters can then increase up to billions. So if you have so many parameters to be trained, then and certainly by good luck you have a good amount of data, then your model will actually lead up to a best or appropriate fitting kind of thing. And then in the deep networks, we had come up with so many variants of the deep network, like deep feed forward network. So that's a typical neural network, MLP, but it is more deeper in nature actually. Then we have other variants of it, and certainly designed for different kind of the problems. So we have like deep convolution networks. We have autoencoders, we have LSTM and recurrent networks like that for more timeline kind of a data. So suppose we are not working on more special data, we have more timely data. So then we need to actually means where when near by instances are correlated, so then we actually use these recurrent networks, or LSTM is a good example of it. Then another is the kind of generative networks like GAN. So this is how we have so many different kind of deep networks which has come up in due course of time for different kind of the problems. So if I further go in a faster pace to take up all these, so if we try to see DC and deep convolutional network, we know what is this. So there are two components of it. The one is the convolutional networks. So it's specifically designed for image kind of the data. So what we do, we have so what we have in case of machine learning, we were to actually do feature engineering there. But now when we see here, so let's say that resolve an issue of doing feature engineering earlier itself. So we shall have a model which actually do that feature engineering. So then we go with convolutional layers added to our deep feed forward network. So this convolutional layers actually does the feature engineering kind of a job. So that is what the thing. So it reduces the pain of feature engineering. That's what the thing is. And certainly what is done in this convolutional network itself, so we do create features. So what happens is we have multiple kind of filter decided. And so if you have multiple kind of filter design, so it could be like we can think of a various kind of convolution being performed, like there could be filters of size 3 cross 3, 5 cross 5, or so and so on. So having an input image, you can generate so many features out of it, meaning that your feature map space is getting increased. But now the problem is, if you are increasing the feature map space, your complexity of the model will get increased. Now how to actually reduce that? Then we have a fundamental of this, that we will increase the number of features and then do what? We will do the pooling. So we will then reduce, and we will actually keep up the only relevant kind of feature from that, and means leave out remaining. So that is called as a pooling. So what we do is we actually reduce 75% of the data and just keep 25% of the important feature maps. And this is a good example for understanding that means feature reduction, or that keeping the more important kind of the features. So just by reducing feature, do we feel that we are losing something? So exactly not. So this is actually showing, means if we do divide these any image like this in different samples, so and we further segregate it, we even have features in each different subsamples. So this is what the idea of means convolution and the pooling network, right? And this is what we do. So finally, at the end of the network, what we get, we reduce so many irrelevant features, and we only left up with the very much relevant kind of limited number of features. And then those features are given for to the smaller size DFF. Means it's not a smaller size. Means it could be very large compared. Means if we wouldn't be having the this convolutional part, so compared to that, we can reduce the size of DFF even by more relevant kind of feature map. And so this is how we see the model. So this is more contractive in nature. The kind of examples we use this is in the image classification problem, localization detection problems. You all know we have huge sort of such classification models in the picture. Good of the examples are like this: LeeNet, AlexNet, VGZNet, GoogleNet, certainly also called as Inception Network. So all these are the huge, means I mean, good of the convolution neural networks. And certainly, as we know, that means every of the new network arrive means do arrive, means they resolve the issues of the previous ones. if we talk about ResNet, so that is what the issue with means. All previous models were having the issue of vanishing gradient kind of the things, means where the we were finding the issues of the dead neurons. So ResNet provide the skip connection exactly. So that means we can go in the previous layers to means better exploit the model. DenseNet is further a mesh network exactly. So in the ResNet we have limited number of skip connection, where in case of DenseNet we have almost a mesh of those connections. So all these are the discriminative models, contractive in nature. Now look on the problem. So let's say we have seen so many problems where we were actually using these kind of deep networks, and we were doing some sort of classification or detection XYZ. But let's say we have a scenario like this. So we have the upper image is suppose a ground truth, or let's say these are the two images. Think on what these tell. So these tell there is a image, two images of a same situation. So same space rather, not situation, same space. So one is before raining, another is at the time of raining. Now the thing is, let's say we are in same car, suppose, and we are running on the road. Let's say I want that. So if it is raining, it's certainly very hard to actually drive. So let's say what I want is means human vision will be giving me the raining image. But let's say means if I can remove that image or de-rain actually my frontal view. So what is that? Even if it is raining, if I can actually employ an algorithm which actually takes the trained image and do de-rain, give me the de-rain one. Oh, then that will be very good, certainly. So this is what the thing. So this is kind of an expectation we need, that my algorithm do de-rain and it will help me in easy driving. So how can that be done? Think of it. So these were the kind of problem which actually came up and ignites the mind. So to actually manipulate those deep network to develop something new. So what is we are doing is we have what is the kind of input. So this is the kind of input in D dimension. Same is the output. The dimension is D itself. But what is happening, or is there's some sort of transformation is happening. Transformation in terms of deraining here. So a model somewhat like this. So a neural network model somewhat like this, where we have input with D dimension, and output again we are saying it's a D dimension output. So but it's a transformed output. So and in middle we have a hidden layers. So however, what will be the dimension of those hidden layers, that's another means game of a study thing. So what shall it be? So we'll talk it later. So this is what the thing we do expect. So this kind of model proposed was termed as autoencoder. So what we are trying to do is we are we are trying to actually, so we already know about the this contractive models, so like DCN. So what was it providing? What means it was providing the more relevant feature at the last stage. So we actually utilize the same approach. So what we do is, so this we actually divide this network into two half. One is called as the encoding network, means that was nothing but more prevalent contractive network. So this was the last stage we were having the the more relevant feature map, and you can say this is a latent space representation. And then further what we want is, now we want it to be transformed into the same dimension output. So then what we have to do is we have to do some sort of expanding kind of network. So then we say it as means a reverse of that contractive one. So and we say it as a decoding. So what is happening is decoding kind of thing is happening. So this kind of network was actually designed and called as autoencoder. So what it is doing, it is taking X input and actually reconstructing a Y, an output of same dimension Y. So this is what the thing. And what is added here, so a bottleneck layer is added here with a smaller dimension M. So it's more like a bow tie kind of a network. That's the thing. So what we are doing, we are reducing D dimension into M dimension, and this is what is happening is we are compressing the feature, keeping only important ones intact. More detailed model means modeling can be seen here. So what we have X is the input, and we transform it to a, a latent space Z, and for where this F is your activation function for the encoder side, and W1 B1 will be your weights and vices. So set of weights and vices. Okay. Similarly, at the opposite side in the decoder, what we will do is we will be actually doing the transformation from Z to X cap. Same kind of activation we are employing here. The only difference here will get a different set of W B means W and B will be there. So that's the decoding kind of thing. So this is to be done. Now, how can we actually model this? So this is what the thing. So so if the dimension of two are same, input and output, so we say that it's a loss-free kind of compression or encoding, and it's called as a under complete encoder. What will be the loss function? How to train it? So there has to be loss function. Loss function will be x minus x cap, the square of it. And then with this loss function, we actually do train this autoencoder. Meaning that we are training it for what? Minimizing this L means we are this model is learned for this W1, W2, V1, V2. All these are what vectors. Right? So now think of a situation. Let's say I in my training phase, let's say I put X at the output. What do you think will happen? So if I put the X at the output means my weights here will get more stabilized, meaning that for a correct kind of output, which is most near to the input. So what will be happening means if I keep this X as an output during training, so this will do a stabilized mapping of input to the output to get a more nearer output. That is what the thing. And this is what the thing we do in case of a typical or a typical autoencoder, or more vanilla encoder means as a plain vanilla encoder, autoencoder. So this is what the thing is happening. So once you train it and when you do want to generate an image output corresponding to input, so this is what an output we get. Now there is one more important thing, a very interesting thing. Let's say we know that my input at any time means there could be the cases that input generally we give might be having noise, but the output I expect should be very clear output. So then how can I do it? So what will I do is, so during training itself, I will add some noise into the input and my output will remain same as the clean output. And if I do that, so this is a scenario what I will find. So what I will, this is my original input, I do add some noise to it and do this training of this encoder and decoder with this kind of output. So means actually the output was there during training, the original output was there. So now once I do the testing with this kind of a thing, so what I'll do is if I actually give only the noisy input, the output will actually be more clean output I will get. Now think of what is happening with this kind of modeling. So this auto encoder where I'm actually adding a noise, this is actually doing what? Denoising the outputs. Sorry, these are denoising the inputs. So this kind of variation of the auto encoder is called as a denoising auto encoder. So exactly what it is doing is it is subtracting the noise. So it is subtracting the noise. So we can see the results like this. So these were the original input, whereas we send what during training was these noisy inputs during training. And once we do it, then at the time of testing, sorry, yes, not at the time of training. So training was done with the means original and the noise. But when I apply this at the time of test, this noisy input at the time of test, what I get is more clean output. That is good beauty of this denoising autoencoder. We have got a good publication based on this. So in Procedia, almost like the same kind of work was there to denoise image. Then we have another kind of autoencoders like means instead of a typical neural network, we actually place the convolutional networks back to back in encoder and decoder. So it can then be good to utilize for encoding the context. So we can see example here. Suppose input is having some context missing. So we can generate that context by such kind of autoencoder. Another good example is UNET. So this is the same kind of thing. What is it is having? It is two VGG network placed back to back. So, however, this has been made for segmenting the output image segmentation. This has been used for image segmentation, and certainly we also use this network. This is a kind of our framework which we use this UNET with two VGC16, and that was to actually segment the brain MRI image into three segments like gray matter, white matter, and CSF fluid. So then it was utilized to do something else thing. So this we had done in our work, and this was published in this cognitive computation system. Now, thing a very important means very interesting thing here. So what we have is uh, what happens. So in case of this auto encoders, we give input, it generates an output nearly same likely output. So if that was the input, we get a nearly kind of same likely output. If this is a kind of input, it will give us this kind of output. Now think, can we generate? So what we are doing, we are actually transforming the input to the output space. Think. So now think is, so these were the kind of output means, is it possible to actually generate more output between these two given? So then it was thought, yes, it can be. So how it can be done? So actually, so then we have to look on the fundamental of the autoencoder. So what is happening in the autoencoder? So we actually transform the X input to the latent Z. So what is Z? So Z is actually a Gaussian distribution. And what is the X cap transformed as X cap, or the reconstructed output we get? So X cap actually is generated from one of the sample taken from this Gaussian. So suppose, and which sample we take here? So what is this Gaussian? So this Gaussian is the Gaussian on the distribution of WB samples, the weight and wise samples. So there can be huge number of weight and wise samples, okay, in the latent space. But actually we are utilizing only one sample here, which is having the least variance. That's a means the sample around the mean to reconstruct the X cap. So, but now we have the scope. Okay, instead of this middle means the single sample with lowest variance, we actually utilize other samples also. Then that can actually give us many other reconstructed images. So this is actually the thing. So what we do is we actually variate the Gaussian with the variance scope here in this Gaussian. So this is what is done here. So for every sample in the latent space Z, we get a Gaussian in the transformed space X cap. And what we are doing is means then, so if we try to see P probability of this X cap, so this will be, so corresponding to every sample in Z, we will get a Gaussian in X cap. So now if you actually choose many samples from this Z, that latent space, you can get multiple of the Gaussians in X cap domain, and that will be nothing but a mixture of Gaussians. Okay? And if you utilize all those, so you can have multiple output generated with a single input, and that is actually, this is the way we can actually find. So this multiple kind of means output you can generate with that, and this variation added into the typical autoencoder is called as a variational autoencoder. So now then if we try to see the limitations of the autoencoder, so there are good limitations, like means these are theoretically complex, and certainly means approximating px is means directly is complicated. So what is to be done is we are more dependent on this reconstruction error, and that actually is having a correspondence with that Gaussian mixture actually. So it is not easy to generalize that with that complex kind of latent space. So so meaning that means they are pragmatically under constrained kind of models. So what then can be done is, so more easier and an indirect approach can be utilized to actually generate or approximate this px, and these are called as the generative networks, generative adversarial networks. Now what are these? So so what we have, so we have the GANs have two models to be trained. So one is called as a discriminator, another is called as a generator. What these do, so discriminator is actually doing the job of classification, whether anything generated by the generated looks to be real or fake. That is what the thing. And the goal of generator is to fool the discriminator. So it actually generates something, try to fool the discriminator, so that discriminator actually says that anything synthetic is real. That is what the thing is happening in this. So actually the thing is, means who is generating is the generator, but now it has to be much more likely looking, very similar to the real ones. That is what, and for that a discriminator is kept for that. So that's the thing. So GANs are actually, when we look on AE, so AE actually are not the generative models, they are more transformer models, whereas GAN are actually the generator models. So this is what the thing we see actually in case of generative adversarial networks. So we have a generator, we have a discriminator, and how a generator generates something. So it actually takes a random Z. So this Z is a very random, you can even say it's like a noise. Okay. So G with an input Z, it actually gives you an output sample like GZ. Now it will be given to the discriminator. Discriminator will actually be doing what? Means it will be applied. It will be actually comparing with a real sample like X. So D of X and D of GZ will be actually it means a difference of this will be checked to check whether this generated kind of sample is actually looking like a real or not. That is what the thing. So dx minus d of gz actually will be your loss function. Exactly not. This is the error actually. This, whether this will be a loss function or not, we will see it. Okay. So so this is what the thing. So z is can be thought as a latent representation of the image, and it can mean it's like a random noise. Like, so that's the same thing I already means spoken. Now how to train this? So this difference or the error or the loss actually is used. This error is backdropped to the discriminator to update the weights. But these here in this case of GAN, this discriminator and generator are independently updated. So means they have an independent job. That's why they are independently updated, meaning that they have a different loss means function for updating the weights. So means once you update the weights in the discriminator, train the discriminator, your generator is logged, and once you update the generator weights, the discriminator is logged. Okay. Another good examples could be like this. So is the same thing, means anything generated by generator here is checked by the discriminator whether it uh, links to same or not. So the idea is to show you those two networks. So this is your generator one, this is your expanding network, whereas your means discriminator, it's your contractive network model. So this is how it goes. Now it's high time to actually show you that good example. Now how to build a simplest GAN. So let's say we have an example like this. We want to generate a GAN for creating the human images living in a slanted land. So they look to be like, means slanted at 45-degree. So let's say, and how to actually represent it? So we can represent it by an image of 2 cross 2 pixels, suppose. So how will it look like? We'll see it. So, and what we will use is, we will use a one layer network to actually model such a GAN thing. So let's say we have, so what we are representing, so slant, so we are actually modeling means, or we are actually utilizing or representing just the face part. Okay. So let's say there could be the face could be different for every different person. So let's say this is one phase, another phase could be somewhat like this, another phase could be somewhat like this, another phase could be somewhat like, let's say we want, now we want to represent them. in a 2 cross 2 pixel representation. So if we try to see this, so when we say 2 cross 2, so higher means, so you have black intensities here at this diagonal, and remaining white intensity is at the another diagonal. Now if we try to now as well see the intensity of this black, so these are gray scale, so it could be very high black or low black or gray scale, low gray scale. That is what the thing. So if I try to see here in this, the second one, try to check these the another diagonal where we are having white here, in second image how it will become. So it will no more remain white, it will be bit a lower gray. Okay, that is what the thing. And certainly likewise we can think of, so this we are having more darker here at this diagonal, so we having we means exact black at this diagonal element, so top left to right bottom. And for this we are having like this, so means it is hairs at one side only, not at the other side. So grayscale at this side, another side it is white. So this kind of representation we can have like this for these face images. So these images represent the faces. Now if I say, means we want to develop a generator network where it will be having a discriminator also, so there has to be a class of non-face also. So if we try to see the non-face, so non-face will look like, means any random value of these intensities, grayscale intensities in these different pixels will give us the non-face. So this is what the thing. If we try to see these segregatedly, so it will be somewhat like this. Now we have to actually then assign the intensities and numerical intensity once we want to develop a model. Take. So how to give the intensities actually? So we have this kind of representation. Suppose, so this is our own defined representation. However, it is reversed in case of standard. So 0 has to be more darker, while 1 has to be more brighter. But in our consideration, what we had taken reverse of it in order to resemble it more clearly with the these phase darker intensities and the means brighter intensities. So 1 means where we have the black higher values, 0 means where we have the white no phase portion component. Okay. So this is what the way we can actually assign these intensities. So now see, now we have to actually go for building the discriminator and building the generator. So let's go for building the discriminator. So let's say take one sample of the phase and one sample of the noise. Suppose so phase, if we try to see, so if I have one this way, this diagonal, so it is a slanted phase. So this is a best example of a phase sample. Okay. So if I do this, now what I have to do is with this kind of a sample, I have to actually design the function. So it's like a neural network function or a classification function or a discriminative function. Okay. So what could be a better function? So I have to actually utilize all these intensity information. So here we have the big intensities, here we have the small intensities. So what I do is, so it better classifies the two is, what I'll do is, so at the diagonal we add up these intensities. So it's like a convolution also. So at the diagonal where one is there, we add these intensities. Where there it is 0 or smaller intensities, we actually subtract these. So this could be, so it could be like a weighted sum. It could be like a weighted sum. So if we do this, so I actually add these higher ones and subtract these lower ones. So means not lower ones. So add these this top left to right bottom, this diagonal elements. So I add these, while top right to bottom left, this diagonal elements I actually subtract. So this is the kind of value I get. So 1.1 plus, so this you can actually do a convolution, you can see well. Okay. So if I do this weighted sum, I get this value as 2. So -1 plus 1, these here -1 plus 1 can act as a weights of a kernel, convolutional kernel. If I actually apply the same for this noise, I get this as -0.5. Now I can put a discriminating boundary here. What could be a bad discriminative boundary? I can have a threshold function. Threshold of 1 can decide this discrimination boundary. So if that is a threshold as 1. So if anything greater than 1 corresponds to phase, anything lesser than 1 corresponds to the noise. So this is my discriminator is. Okay. So this is I shown with my convolutional operation. Now I have to transform it to a neural network. So I will have a neural network like this: 4 inputs for 4 pixels, 4 input neurons for 4 pixels, and one output for the output level. So 2 neuron corresponding to these 2 pixels, and they will be means they are of same type, contributing to the phase. So I put them with a red color. Another ones they are not contributing. The neurons I'm connecting to the output with another color like. So now think of what should be the weight. So weight I can have is means the convolutional filter weight, the same kind of filter actually will give me a good discrimination. So जो 1 1 से थे, so all that these link I will be giving them +1. All those which were at the another diagonal with a smaller intensity value, I give them -1. Now see this, my neural network, how will it become? I will add a bias also with weight -1. Now see, take the example. So do the weighted sum. So 1.1 plus 0 dot minus 1. So this comes out to be 1. So this out comes to be 1. Now what I will do is, so instead of taking this output to any value, what I will do is I will actually put it into the range of 0 and 1. So for that I will use a this uh, sigmoid function. So sigmoid activation I will use. So I will apply a sigmoid activation on this weighted sum. What I get is the sigmoid of 1 is 0.73. And from here it is well clear. So 0.73 is more clear, nearer to 1, means it is greater than 0.5 mid of this function. So it is of the class phase. Okay. And similarly, if I check this same neural network with these weights for a noise class, so what I get is, so this here I get is the sum is minus 0.5, and I apply a sigmoid, I get the value is 0.37. Certainly, it is less than 0.5 in the sigmoid, so it will be the noise class. Simple. So these are the weights I decided with our own understanding. Okay. Similarly, if I go with the generator, use the same weight, suppose. So this is what the thing. I use the same weights for the generator. Okay. So where I was having a larger value, I use the weight +1. Now, what will be the input to the generator? So input side is a single neuron, output side is 4 neurons. Okay. So input is a random noise. So how will I generate a random noise? This Z by a random generator, random number generator. Suppose I generate a first sample as 0.7. So now these are neuron connection. I actually make it for the higher value of the intensity at means at this diagonal element. So the weight I assign is +1. The value I get is 1.7. For the smaller means other diagonal element, I assign the as I had taken from the generator discriminator. So these are the values I'll get. So I do take the sigmoid of it. So what I'll get is these value 0.85. So now these will be my intensity value at in the image generated by my generator. So this is what the thing. Now you can well realize that this actually correspond to a slanted phase. Okay. So higher values are at this diagonal, while current lower values are at another diagonal. So this is how means, but this was means these weight assignment was based on our own understanding. Okay. But now the thing is, let's say we do not know the weight, we have the random weights, so actually the weights were not assigned at all, but we want to train a network for updating the weight, suppose. So how can that be done then? So this is what the training process we have to then apply. So for that we have to have a error function. So what should be the loss function? So the better loss function is like this. Level for level 1, if the prediction is 0.1, the error is what? Very large. So 1 minus 0.1 is very large error, 0.9. So for large error, we shall have a larger value of the error. Okay, or the error function. So suppose some, or for a smaller value we are getting error is prediction is 0.9. So very close to level 1. So error is very small, 0.1. So what should be our loss function which can actually, for a smaller error, it shall give us the smaller value in the error function, okay, or the loss function. So actually what we get is the minus ln of the prediction actually we give us this kind of the values. So this, so means this is like this. So ln of prediction here, ln of 0.1 is 0.2, 2.3, and this is a very larger value, and this is sufficing that larger error, okay. Compared to this smaller error, if I do ln of this prediction 0.9, I get this 0.1, and this is a smaller error coming out of this loss function. So this happens to be a means minus ln of prediction happens to be a good loss function, compared to if we see in the zero class, when the label is expected to be 0, if a prediction is 0.1, the error is small. If the error is small, we also expect what, that error function value should be small, okay. But the ln of prediction 0.1 will not be what, the ln of 0.1 will be 2.3, which is large. So what we will take is, here in this case we will do 1 minus prediction, the minus ln of 1 minus prediction, minus ln of 1 minus 0.1 is 0.9, and minus ln of 0.9 is 0.1. Then this suffices the smaller value of the loss function, with corresponds to a smaller error, okay. So error function or the loss function is in case of label 0, noise, the it is minus ln 1 minus prediction, while in case of the phase, it is minus ln of prediction. So this is what the prediction means the loss function we had actually defined for this, okay. This will give us very good kind of the result, okay. Now what we can do, we can train with these error functions. So a random z, a random w. So with random z or random w, I will get anything like this, okay. Now I will check it. So this is my generated image. Now I will check it with a discriminator whether it goes correct or not. So now what the value I get with random w, let's say 0.68. So 0.68, it is telling that it is greater than 0.5, but it happens to be wrong. So meaning that, then since it is wrong, then this error function will be utilized to update the weights in the backward propagation manner. So what it will do, so we want a 0, but it is giving 1, okay. So we will use error function like this, so loss function like this, minus ln of 1 minus 0.68, this will be updating the discriminator. Compared to this, what we want at the generator, we want a actual, means the face image generate to be generated. So we want one at the generator side. So the error function for that will be minus ln of the prediction, that is 0.68. So this error here, this will be utilized for the generator, means weights in the generator updation, the weights in the generator, and the another will be at the discriminator side. So this is how, and these iterations has to be repeated, and certainly at the very end we will get you will reach the exit condition will be where you reach the global minimum in the error, and that is what. So this is how your dragon, means your GAN is trained actually. So this is all. So if any question, if anything you have, so actually I had taken a complete time, it's complete 1.5 hours. So if there is time left, so you please you may put some questions.
Yeah, we can take questions for next 5-10 minutes.
Please.
Any question, type over the chat box or raise.
So I have to go through the chat box, is that?
They can,
Yes, sir.
you can raise your hand.
I don't know whether it was means really in a grasping mode kind of thing or not. So it happens to be bit faster actually. So bit more time was expected.
Participants, please ask the question. This is very holy presentation. You know, it is coming directly from the place of Kumbh. Take advantage.
But see,
Participants, if you have any question, you may raise your hands or drop the message in the chat box. Please ask the question if you have any query.
What happened today, participants? It is only fourth day. We are only ahead of. I think most of the participants got the things in the way you have explained.
but as you pointed out, me is coming from the place of a so I even feel that this presentation, so it's having so many things. I even admit that. So it's again looking like a comb itself of the information.
Thing is complete. Okay, Arshi, so you can conclude that.
Okay,
Mostly
sir.
participants are responding that they are getting. So just
Yes,
keep.
sir. Thank you so much, Dr. Dushyant Singh, for the insightful and engaging session. I'm sure our participants have gained valuable knowledge from your expertise. That's why they haven't asked the questions.
It might be other way
Now,
also. I don't know.
yes, sir, surely they gained the information from your session.
Thank you. So all right, so shall I stop it? I shall
Yeah,
leave.
yeah.
Huh? I think.
Thank you,
Okay.
Dr.
Thank you
Dushyant,
very
for
much.
your nice talk and
Thank you
excellent
very much,
discussion.
this coordinated team for inviting me. Thank you once again.
Thank you so much, sir.
Start next presentation in 5-10 minutes because that speaker has some technical issue. So he's going to join in 5 minutes.
Yes, sir. Participants, please wait for the 5 to 10 minutes. Once our speaker will join, we'll start the session.
You can take a small break. joining now. Here is the analytic company BambooBox. Yes, Divyesh, have you joined? Hello, Divyesh. Arshi, can you unmute him? Allow mic. Okay.
Sir, I think he's not there. I cannot see
He's
him.
there. Divyesh, search Divyesh. Enable his
Okay.
mic.
Okay, sir.
Yeah, I think it is enabled now. Check.
Hi everyone, can you hear me?
Yes. So
Okay,
Divyesh is here. So Arshi, please start.
Okay, sir.
So meanwhile, you can share your screen so that we will check. Arshi, start.
So, good evening, one and all. So, continue with the next session with our next key speaker, Mr. Divyesh Dixit, who will be enlightening us on the topic Generative AI Application in Marketing.
Anurag, I think
Uh,
my sharing also need to be enabled. So while the sharing is getting enabled, so hi everyone, and sorry for the delay. Actually, my net had issues at the last moment, and that's why I got delayed. So sorry about that. My
So,
name is Divyesh Dixit,
yeah,
and
Divyesh. Meanwhile, they are enabling your sharing, and our one of volunteer will introduce you. Then after that, you can start.
okay, I think yeah,
So,
okay,
Parvez, please enable Divyesh sharing.
yeah, I think
sir,
it got
uh,
enabled. Yes.
should I continue?
Yes.
Okay. Uh, So let's continue. So it's our privilege to have with us Mr. Divyesh Dixit. He is co-founder BambooBox, an AI-powered B2B marketing platform that unifies customer journey data across multiple SaaS applications. With over 20 years of experience in software product development, he specializes in AI-driven personalization, predictive analytics, and automation to enhance marketing efficiency. Mr. Divyesh holds a BTech in Materials and Metallurgical Engineering and MTech in Application of Neural Networks and Genetic Algorithms to steel making process from IIT Kanpur, where he was recognized with multiple awards for academic excellence and research contributions in artificial intelligence and machine learning. He later pursued an MBA in marketing, combining his deep technical expertise with strategic business insights. His academic background has played a crucial role in shaping his approach to AI first marketing automation, growth frameworks, and product led strategies. As an industry leader in AI driven marketing and agnetic workflow, Mr. Divyesh has been instrumental in developing scalable AI-powered solution that improve customer engagement, lead nurturing, and revenue generation for B2B enterprises. He is currently spreading the development of Lumo Agent, an AI-powered system designed to enhance B2B intent campaign by significantly improving engagement rates through AI-driven personalization. A recipient of prestigious award at IIT Kanpur, Mr. Divyesh is also a key contributor to Mavens, a community of CMOs and marketing leaders where he shares insights on B2B growth strategies, startups, pivots, and AI application in marketing. He passionate about the building anti-fragile system, leveraging AI for business impact, and shaping the future of AI-driven marketing automation. With that, I now invite Mr. Divyesh Dixit to take over session and share their valuable insight with us. Over to you, sir.
Okay. So, hi everyone, and good evening to all of you. And thank you for such a lovely introduction. Uh, so, I'm going to talk about generative AI application in marketing. And I think there are two type of marketing. First type of marketing is B2C, business to consumer, and second type of marketing is B2B, which is business to business. And Gen AI is making inroad on both of these areas. And in fact, marketing is one of the top areas to be changed by the generative AI. So some of the other top areas are like software development and coding, customer support, and then marketing is also one of the areas that is going to change a lot with generative AI. So if we look at the top, that how has generative AI has been changing in last 2 years, the marketing field. So these are the five areas, and I think some of the areas many of you might already be familiar, and some of the areas I'll throw more light on it. So the first area that is very much shaking up the marketing is the automated content creation. So actually, the content is a very big piece in any marketing campaigns. So let's say when we talk about shooting an ad, so first of all, you need to get models, you need to have proper setup, then you need to shoot videos, or if you are creating images. So a lot of resources get spent on the content creation itself because the content need to be very top notch for any company to use it in its campaigns. Now I'm going to show you some of the recent ads which are created by AI itself. And I think the reason that companies are leveraging AI is not because of low cost right now, but because of novelty factor. So let's see that one of the ads by one of the brand. So are you guys able to hear the sound and video?
Video, but not sound.
Okay. So okay, so I think video is enough because you will get a sense. So as you can see that this does not contain much of the reality. So you can see that this ad was totally generated through AI. Nothing in this was real. You can see. uh, So in fact, this ad can be created by now some of the video editors, AI-based video generators in very less time, and it still looks quite professional, right? So I'm going to show you the next ad, which is done by Coca-Cola. This was done by, again, by AI. And you can see that Coca-Cola has got tons of money. And this was one ad campaign that they ran in Christmas. So you can understand that Coca-Cola has a lot of budget, but they still choose AI to do this. And you can see that most of the things are artificial. So you can see that that the video was totally, and it is created by something called Real Magic AI, which is the name of the software. Again, there are a lot of video creators, like you might have heard about the OpenAI model called Sora, and and then a lot of such models are coming, and the marketers are using some of these videos. So continuing the theme, I think you can understand that a lot of you are using ChatGPT to create text-based content. There are Mid-Journey, again ChatGPT for images, and there are a lot of models are coming every day. There are audio-based model called Suno, uh, through which you can create sounds and music. So a lot of these things are getting used by the marketers, and this is going to change the way the marketing is getting done. Okay, so I'm going to also talk about the second topic, which is the personalization. So not only you are creating the content, but also you are personalizing. Uh, so I don't know whether you are able to hear this sound. Uh, Hi, Divyesh, this one's for you. 2025 is right around the corner. So in the beginning of the video, so this is a video by uh, the founder of Peak XV, which is a VC firm, and he sent me a message, and he sent that message to at least 100 people. But in the video, everybody's name was taken in the beginning. That hi Divyesh, this is a personal message for you. Again, there is a company called GAN.ai, where you could generate video, personalized videos. So you just give the text script, and the model will create the video, which is very personalized for you. And I think some of the companies, they were using this kind of models in election campaigns, where you will get a phone call from Modi, and Modi will say hello, and then he will take your name, and then he will continue with the message. So I think a lot of content that will be generated will be one-on-one. So that is the second use case of generative AI for hyper personalization. So I'm going to spend a lot of time on today on hyper personalization, and then we are going to spend some time on these topics as well. Uh, so is it going to be unmuted, or I will have to keep talking? Are there any questions or comments?
So if participants will have any question, they will type over the chat box. So you can see from there. So participants, if you have any question, you may type over the chat box so that Divyesh can see and answer.
So I think please keep coming with the comments and questions, because otherwise it will be very difficult to just keep talking whole the time. Okay, so let me move on to the next personalization area. One more case study I'm going to talk about. So this is one that I am building at BambooBox. So I'm going to go much more detail into this. Uh, so we are building uh, an agent. Now, agent means that it will take most of the actions by itself, and it is going to do all the things by itself. Just we will give the instruction in the beginning and it will take all the decision by itself. So that is also uh, latest thing about generative AI is that agentic AI is getting very popular.
Excuse me, sir. Sorry to
Yeah,
interrupt you. Sir,
yeah,
can you share your screen with full sharing mode so that
yeah.
it is more visible to the participants?
Okay. Is it fine now?
Yes, sir. Yes, sir. Now it's
Okay.
full screen.
Okay. So I'm going to talk about Lumo. Uh, so first I'm going to talk about the problem that why did we created Lumo, which is the agent we created. Uh, so this is in context of business to business marketing, where generally you might be getting a lot of emails, right, from different companies. And as a result, uh, people are not opening some of those emails because they are getting too many of them, right? So generally current open rates are around 15% when a company sends an email to people who could buy the software. Only open rate is 15%. And click rates are also much lower, where you click on something and go and check out the things. Second thing is that it is very difficult to do personalization, so nobody does it. And the third thing is that even generic emails people are not able to run regularly because they they are not able to do all the work required to do the campaigns. So what the campaign means is, let's say sending an email to 500 people. So that is an example of a campaign. Now to do that, you will have to create some kind of copy. Copy means what text will go. So you have to write the email, and the email should be written very well. So a lot of marketers take a lot of time to write those emails, and as a result, they are not able to run more than 3 to 4 campaigns in a month. Uh, then post that, there is a teams called SDR. So now I'm going to spend some time on SDR. These are called sales development representative or called business development. Their job is to set meetings for the sale. So now marketing sends a lot of emails. Post that, whoever is showing interest, the SDR teams follow up, and generally their job is to make sure that they study about you online, and then they personalize their email. But many times these guys are also very busy and they're not able to write very good personalized emails. So these are the problems that we are going to solve through Lumo. So this is a kind of architecture of Lumo agent. So this is a BambooBox product, uh, which is a kind of data warehouse where we collect all the marketing related data in our data warehouse. So it will get a few signals from here. Then it is going to go let's say I want to write uh, an email to Mark Zuckerberg at Facebook. Okay. So now it is going to look up the Facebook company profile, that what does Facebook do, and it will also read about from their LinkedIn page what they are trying to do in the next year, right? So then I'm going to search, let's say Zuckerberg, what kind of podcast he has spoken in, and I will get all the podcast data about him. Uh, Second thing is that I'm going to look at the location where he's located and what are the sports events happening around him. So, for example, let's say if somebody is uh, in Bangalore, so I'm going to look up on Perplexity the news about Royal Challenger Bangalore, or I'm going to see that what sports are happening in that location. Second thing, then I'm going to also look at the news and see that where that person is mentioned or where their company is mentioned. So I will also get that data into Lumo Agent. I'm also going to go to their website and also their blogs. So all of that information I'm now feeding into Lumo Agent. So now again, Lumo is not going to prioritize or process raw feed from directly from all these sources, because this data will be too big. So now in between, there'll be multiple steps where it will use LLM. So in this case, we are using OpenAI ChatGPT model through API, and we will, let's say, summarize, let's say, website information. We will summarize signals. Then we will identify that what they are looking for the next 1 or 2 years, right? What are their current challenges? What are the pain points that they are having? And then finally, once we able to summarize all of these, then we will draft email using the OpenAI. Okay. So let me just see that any questions on this. Okay, no questions. Is the architecture clear? Okay. So let me move on and give you some examples. Let's say there is, I'm writing an email to a person named Varun who is working at Browser Stack. So I will go and get his email address from BambooBox data warehouse. I'm also going to search for his LinkedIn profile. We are using some APIs to get the LinkedIn profile also. Now, this is the text that we could find in his LinkedIn profile. So he was working in government sector, and then he came to Browser Stack, and he has some years of experience and as a marketer, and he has trying to grow the revenue. More importantly, it also sees that how he has as a person, right? So he's very interested in music and musical instrument, and he loved to play music. I think it might also be that he loves to play cricket also. So I think it is. So he loves to play and he's interested in music. So now when we collected all the data and then wrote an email about to him, right? So this is a email generated from the Lumo agent, and there is nothing edited here. It is coming straight from Lumo agent. So you can see that the first paragraph is very much personalized to Varun. And the second paragraph is about the topic that we are wanting to talk about. So what we had done is that given a link to Lumo, that this is the article that I want to send to him. So it created this paragraph by reading that link.
Excuse me, sir.
Yeah.
Sir, there's a question in chat box has been asked by Dr. Praveen Das. What
Yeah.
industries can benefit from Limbo Agent's generative AI capabilities?
Yeah. So right now, I think we are focused on B2B marketing because one thing is that this level of personalization is not common in B2C industries, because let's say Parleji will not write you an email to buy a biscuit, but uh, these B2B products, let's say somebody is selling you software, then they are going to write the email. So generally it is or let's say Infosys is trying to get some projects from, let's say, Mercedes, right? So they will identify some people in Mercedes, and they're going to write emails to them talking about how Infosys has helped other companies to streamline their software development or IT. So generally it is a business to business where a lot of email is there, and personalization of email is also very much prevalent. So again, the tech industry, the companies that are selling software, the services industry, the companies that are selling technical services. Um, yeah, I think wherever it is business to business, it is going to be used heavily. So you can see that it started talking about music, and we are sending him about the marketing. He's a marketer. And then you can see that it picked up that he moved from government job to marketing at Browser Stack, right? And and then uh, you can see that kind of language also it is using. It is related to music. So you are hitting the right notes in your career. So it's not just picking up like music, but it is also starting to talk in his own language, which he might relate much more. Okay, let's see that how the personalization could be done based on a podcast. Uh, so this is one of the person at Hitachi Ventara. Now he had talked on a podcast, and so he discussed about data management and IT with Hitachi Vantara. And I think 99% of data that companies collect, it goes unanalyzed. So IT strategies. And so this is about his podcast, right? So now you can see that how it is personalizing this email. So it is saying that the subject really enjoyed your take on data management. So the agent is coming across as a real person, and so it is starting to talk from the podcast itself that I saw your great talk on this podcast, and you mentioned that 99% of data collected is not checked. So your ideas on how companies can do better with good IT plans were really inspiring. Then again, it has to talk about what we are trying to send email about. So, uh, so I want to share something cool from BambooBox. It talks about how to use intent data in AVM. So again, it is talking about the BambooBox product, and then it is giving you the blog link, and it is looking like a human to human mail, but again, this can be generated at scale, which was not possible before the generative AI came into picture. So this is another example. Let's say it did not find much about Kelly either on LinkedIn or on podcasts. Now it only knew that it is she's coming from Minnesota. So then it goes and searched on the perplexity that what are the latest sport news in Minnesota. and the team that is popular there is Minnesota Viking. So it is uh, it is saying that just like the surprises from Minnesota Viking this season, B2B marketing can be a tricky game. So seemed like there was a match which was very surprising and it picked up from there. So it is connecting to the audience in the first line. Then it is talking about their company and what is she doing, and then again this is the third paragraph is about us, and uh, again here the blog link is given. So you can see that this each email for every person is a very different email, right? And it is trying to connect with them at the personal level. uh, so this kind of personalization is possible in B2B world. So any questions on the Lumo agent before we move on to the next case study on the personalization front, which is more on B2C domain? Okay, so I will move on to the next case study. So this is a case study on business to consumer side. So there is a platform called Ampay, which is creating agents for sending like email, WhatsApp, uh, chat messages, SMS, uh, these kind of things through the B2C application. For example, if you have installed Zomato or Swiggy, you might be seeing that it keeps on sending you message every day, some or other message. Let's say if match is happening, it will say that pizza and match go together. Let's order pizza, right? So this is the kind of software which is running behind the scene uh, uh, in, let's say, Zomato or Swiggy, right? So how this works is that, let's say Zomato or Swiggy is the business. So they will define that what is my objective. So again, they want to drive some people on their app to open certain type of screens, or they have launched a new service. They want to have people come to that screen. So those are objectives. Let's say objective is that they should open my app every day 2 times. That might be one objective. Or they should at least once in a week put an order on Swiggy. That might be another objective. Uh, and then they will also define certain triggers. So these triggers can be hard-coded things like, let's say, festivals or matches, or let's say uh, triggers can be time-based. Let's say if it is breakfast time, then 8 o'clock might be a trigger, right? And then they can define constraints. So constraint might be that don't send more than 3 messages in a day. Uh, so whatever happens on the app, it is captured through something called event data. So actually they are capturing each and every move that we make on the app. For example, if you open a screen, it will capture that you opened a screen, and that data will go into a data warehouse. Second thing is that you were there on that screen for 10 seconds. Even that is an event. So whenever you leave that screen, it will send that duration that you have been there on that screen was 10 seconds. So there is something called customer relationship management. So it will pull data from that CRM and it will create list of people, and they are running something called agent. So again, agents are nothing but a piece of software which has access to certain model, and they are able to take actions in the real world, and they are able to observe some consequences, and they are able to achieve certain goals. So these objectives, strategies, and triggers, constraints, they define goals. Then this inventory of messages. So this is the content. So this is the inventory of messages that an agent can send. So uh, let's say for today, Swiggy has got list of 10 messages that the agent can send. Now agent is going to decide that I'm going to send message one to set of users, message two to these set of users. So that it will define based on the intelligence that it derives. So then it is going to define that what time to send you the message, what channel through which you are going to read more, and copy means among the what ad or what message. So these three things are decided by the agent itself, and agent will take the action, and then it will learn from those actions that if I am sending user WhatsApp message, if he does not read, then next time he's going to use SMS or he's going to use email. But let's say if I am going through email more, I'm clicking more through the emails, then next time it is going to send me through emails. So again, it is a very intelligent agent where it keeps on learning and it keeps on optimizing. So again, if you want more details, these are available at this link, and you can see that. So the agent keeps on learning that in the beginning it sent few messages, but the user did not respond. Then it kind of uh, sent less and less messages. But when it saw some activity from user, it started sending more messages. And finally, that user bought something. So these agents keep on trying things and keep on learning. And again, this is also powered through Gen AI, where it will create variation of the messages based on the user profile. Just now, as I showed you on the Lumo side, uh, so again, to give you one example, that one of the customer was using Ampe and then they stopped using it. So they stopped using here. And as you can see that their revenue started dropping. People stopped doing less number of orders, and then they turned Ampe back on. So you can see that how some of these agents which are personalizing, they become a very much essential part of a business like Swiggy Zomato. So let me see any questions are there. Okay, so there is a question on the ethics and data privacy. Uh, yeah, so definitely when people are using these things, there are certain ethical consideration. For example, when you are creating offers or when you are doing some sort of decision which can impact their lives. For example, some of the people are using Gen AI to do decisions on whether to give loan to a person or not. Now, if there are biases in that, definitely it becomes a question of ethics, that how do we create models that are unbiased? Uh, Second thing is that while we are generating, the output should also be not be biased. So for example, I think Google's Bard, when it was generating certain facts, I think it did uh, some mistakes related to historical accuracy of facts, and it showed some of the historical figures as black figures because again their model was trained in such a way that it tried to give equal representative representation to black and white, but again it got historically incorrect. And I think those are the points are there. uh, I think another ethics point is that AI is going to take a lot of jobs, right? Because if it is going to replace people, then is it ethical to work on AI development or not? So again, this question is not yet very clear that whether it will cause job losses or it will make everyone so productive that we will start having some new different type of jobs. And maybe uh, for example, when the tractors and agricultural machinery was invented, people thought that uh, that farmers will not have any job, right? And in fact, over time, the number of farmers kept reducing, and then people found other jobs, right? So again, how does the AI plays out? Uh, uh, that is still uncertain. Now, coming to privacy, I think we will have to draw a fine line there. For example, this email, right, where we learned some personal fact about him. So again, it is a very tricky edge where we should not spook some user by knowing too much about them. As long as it is used in a right way, I think it can still go well with the consumers because everybody like to read the kind of language that they like. And if let's say while talking to HR, it is talking more in softer terms like motivation, and while talking to CFO who want to talk very hard numbers, so there you'll have to talk in terms of percentages. So there also it can make a difference where the language used is relevant to that person. But yeah, again, privacy is a bit of tough job. And some of the privacy things are that whatever data you collect about someone, don't sell it to other third parties, don't share it with other third parties. So those are the uh, pros and cons of privacy. Okay, so next thing I'm going to talk about is uh, on the AI SDRs and autonomous marketing agents. So, so agents are nothing but a model uh, embedded within a system which has got access to multiple tools. So maybe I'll just show you another slide. So just I'm sure that you guys are in this field, so you might already be uh, very well aware of what are agents. But agents are systems which has got following components. The first of all, the whole system is called agent, and agent should contain an intelligent model. So the model which can reason and which can also understand natural language. Another thing is that agent should have tools. So there should be a set of tools available to agent, and then agent has got a loop. So the agent is going to take instructions from user, which will be a goal. Now agent is going to go into a loop. For example, it will go to model, talk about the initial question. The model will throw that you should use this tool, search tool first, and then call this tool with these inputs. So the agent will call that tool. Whatever it gets back from tool, again it will feed into the model, reasoning loop will go, and then it will suggest another tool, and then it will keep on happening till the time the job is done. So for example, here, when he said, I want to book a flight from Austin to Zurich. So the model gave the thought that I should search for flight. That means it is going to use a search tool. Okay, I think in this case, action was flights tool. So then the input was that search for the flights from Austin to Zurich using flights tool. So flight tool returned many options. Then he said that I should present to these users. So then it will give back in the chat that here are some flights. So this is kind of agentic loop that people will say, and then agent can be connected to APIs also. So API is nothing but a tool. So as you might know that, okay, there are models like OpenAI's Llama 3, uh, the DeepSeek. These are the models. And then there are agents. Uh, so models, the limitation is that knowledge is limited to their training data. While agents knowledge is extended through connections with external system. So for example, it can connect to a database. So RAG or retrieval augmented generation is also one of the tools that agent could use. Uh, Again, there is a single turn, but here it goes in a loop, right? The tool, there are no tools available. Here tools are available. And here reasoning is very important. Here there is no logic layer. It is mostly input and output layer. But here most of the agentic system will have a reasoning model. So that's about agent. So let me talk about how the agents are coming up. So I'm going to talk about one more company called Lizer. Okay. So Lizer is giving framework for agents to companies, and they're giving some pre-built agents. Now, the first agent is Jason, which is an AI SDR. Scott is an AI marketer, and Dan is AI HR. So again, they have created these agents based on the input-output model, and they're already pre-trained. Then they're giving some applications, AI applications, chatbot, knowledge search, data analysts. Uh, and then companies can also create their own AI agents. So the interesting thing says, let me talk about the AI SDR. So AI SDR's job is to connect people on email, LinkedIn, or other channels, and then try to reach out them over phone and try to book a meeting with them. So they don't do any selling. Their job is to get meeting done. And generally they do high volume of activity. For example, they might do 50 calls a day, or they might write 30 emails a day. Now, some of these guys are very busy. So for example, if in customer replies that how does this work in your software? So most of the SDR will not have knowledge to immediately reply to that email. Now, some of these agents, the AI agent is intelligent enough to pull that information from knowledge base and automatically reply to that customer. or let's say customers sends an email that I am available at 5 p.m. tomorrow. Now SDR will have to go and read that email, then send a calendar request, right, at for 5 o'clock. Now this AI agent will automatically do it. As long as it reads the email, it will identify that what is the action. Again, it will have a calendar tool available. It is going to book a calendar request with the customers. Some of these agents are also able to make calls. So uh, one of the examples that we are seeing a lot in field is that small businesses like, let's say, garage. Let's say your car is due for service now. It has been there since 6 months. Now, again, you need to book the service. Now, earlier, the receptionist would call us and they will say that, sir, your vehicle is due for service. Uh, uh, when do you want to drop the car for service? Now, all these things are getting done by AI agent, which can also call automatically. So it will call you whenever the service is due, and it will ask you. So it is again two-way. It is able to speak and it is able to understand in real time uh, that what you are saying, and derive that, okay, you want to book a meeting tomorrow 5 o'clock, or you want to drop your car next Sunday. So all these agents are getting very intelligent. So working through email, working through phone, these AI agents are doing a lot of jobs. So another thing that search engine optimization is another area where let's say, how does the customer reach out to you? Normally they come to your website and they will search on Google to find your website. Now there is a whole field called search engine optimization where you make it easy so that they can come to your website. Now what people do is that they will write text in on your website in such a way that Google will uh, index it well in their search, and then you appear towards the top of the search results. So I think one of the companies is creating content bots which can write articles on your website so that when somebody goes and does search on Google, your website will come at number one. So there are different types of bot they have created. So there is a one bot which is writes about cybersecurity. One bot runs about fintech. So that is there. So let me also tell about one more agent, which is full workflow is there. Okay, so let me talk about one more thing, that how having the agents will is going to change the nature of economics of software also. Uh, so right now the software is sold as per seat, right? Let's say somebody is running call center and they are having 100 call center employees, so they will buy a call center software per seat basis, right? But now once these agent come into picture, now the company which is building the agent, not only they can charge per seat basis, but they will be resolving tickets. So their value is going to be very high. For example, in a ticket resolution through Zendesk, the human cost is around $37.5 and software cost is 69 cents only. Now, if some company is building uh, an agent which can not only do the calling itself and resolve a lot of tickets in very short time. So they can go and start charging instead of 69 cents, maybe $20, because right now it is costing them $38. So this is called outcome-based pricing, where the agents are going to sold not as a software, but as an outcome. So they will not say that I'm going to sell call center software. They're going to tell that I'm going to solve your customer problems and I'm going to take care of you. You don't need to worry, and you just pay me this $20 per case. So I think now some of the softwares will move to outcome-based pricing, and that is where what kind of outcomes you provide, that will determine how much you can charge. For example, if you just charge, send me unqualified leads, that is going, I'm going to give you only like 1 cent to like 20 cents per dollar. If you qualify those leads, that means I'm going to give you 10 cents to 50 cents per dollar. If you book the meeting for me, I am going to give you 2% of the money. The second thing is that if you follow up the meeting also, and you create opportunity in my CRM, that means it is already very well ahead in the sales cycle, then I'm going to provide you up to 5% of the whole deal. Now, if you just send me the whole signed contract, I might give you 10% because I don't need the sales person also. Now, if you give me customer and you you also service them, then I might just take a cut of 30% for myself and you keep on doing all the work. So that's the power of the agents, uh, even in the marketing area. So these are all marketing and sales area, and outcome driven pricing is going to be one of the big things. Let me talk to you about the last uh, AI agent use case. I think the HubSpot and Salesforce. Uh, so Salesforce is a very big company, and they have given in a very big way on the agents. So they have launched agents for sales, for services, for marketing, uh, for the e-commerce. Then they have for salespeople. Uh, I think one of the important areas that Tableau is, it's an analytics platform. So generally people find the analytics software very hard to use. Now this agent for analytics are becoming a major thing, where instead of looking at the graph yourself, you can ask that what is new in this graph, or you can ask just a question that what is pattern in my sales, and it is going to tell you that sales has been increasing at a rate of 10% per month since last 1 month, but this month it has gone bad. Now you don't need to go and look at all the data. The agent is going to answer you those things, right? So the Salesforce has taken it in a big way. Uh, so coming back to our topic, so I think we have covered automated content creation, uh, and I think you guys are very well aware of different tools to create text, images, and videos. We have talked about hyper personalization, where I took three use cases. First was that personalized video, which is just for you. Second was that Lumo agent, which my company is developing, where it can create a one-to-one personalized email based on all the data it collects from the web about the person. Uh, Third example, we talked about where the messages on apps like Swiggy and Zomato, how they can be personalized and their timing can be adjusted based on your personalization. Uh, for example, if you get up early and have breakfast, then the Swiggy will send you that message earlier in the day. And somebody who is a late riser, they will send them message late in the day. Uh, Again, like lot of personalization happen. Then we talked about AI STRs, where uh, the agents are doing automatic follow-up, automatic calls, automatic emails. We talked about agent framework, where not only the model is there, but model has access to a lot of tools. Model can do reasoning, logic, and then it can keep on observing that what action it did through the tool and what was the result. And then based on that, take the next action again. And then it goes on a loop. And then it can do very powerful things. We also talked about how companies are moving towards outcome based pricing now with the agents being there. They not only want to sell the software, but they want to do the whole job. So any questions till now before we move on to the next three areas? Okay, so I think there is a question from Ankur. So Ankur, yeah, so I think in general, there are, we as a layman do not understand the difference between marketing, sales development, and sales. For us, all three are same because we go to market and buy, and somebody who's selling us is doing marketing. But there is a subtle difference. And what is the difference? So marketers generally talk to lots of people. So they don't do one-to-one message or one to few. So for example, marketer will send a message on the TV, or they will send email to 1,000 people. So it is one to many motion. So 1 to 1,000 people. It is not 1:1 communication. Now, when it comes to sales development guy, and marketer's job is to create awareness about the product in the market. Uh, his job is not to finally close the deal. His job is so that more and more people can know about your product in the market and they come to you. Okay, so it is more about awareness and lead generation. Now the job of SDR is 1:few. So they will run after few people and they will try to personalize their messages. They will see that they will try to connect, and they will try to see that what is your budget, are you interested or not, uh, and what is the budget you have. Then based on that they will set the meeting. So that is the SDR job. Now finally the sales guys come into picture, and their job is to close the deal. And they are mostly one-to-one communicators. They will give full full attention to one person during that deal. And uh, whatever they create, like they will try to understand customers much more deeply, and they will create a proposal such that customer cannot say no. So those are the difference between marketing, SDR, and sales. So the in the first comes the marketers, because if nobody knows about your product, they will not come to you. Then comes the SDR. So SDRs are which are doing follow up. And then finally comes the sales guy, right? If we take one example of B2C company, let's say you are going to buy a dress or a shirt, t-shirt from, let's say, Arrow. Now, if you do not know about Arrow, then you can't go to a Arrow showroom, right? So first you would have heard about Arrow somewhere. So you might have heard about Arrow in the ad, or you might have seen a ad on your online ads when you went for search for shirt. Then you saw at the top the Arrow's name. These are all things marketing. Now, uh, let's say you might have seen that some people who are running outside the shop and trying to get the customer in their shop. So those are kind of SDR. I mean, in fact, B2C does not have much of the SDR role, but at a crude way, some of the guys who are there outside their shop and they're calling in. Now, those are the SDRs. They're just getting the customer inside the shop. Now, the sales guys are at the counter and they will see that, oh, how like what kind of money you have. They will bring those kind of t-shirts to you. They will say nice things that, okay, t-shirt is looking very nice on you, and they will try to close the sale. Maybe they might say that, sir, offer is there today, just buy it today itself, 10% offer is there. So those are the things. So that's where the marketing agent will go and target broad people. The SDR agents will work on a short list of people who are shortlisted by marketing, and SDR will try to set book meeting with them. So that is why the marketing agent and SDR agent are two different things. Okay. Okay, so I'm going to talk about data quality and data privacy. So yeah, I think the Gen AI has a lot of potential in this area. Generally, uh, the sales guys do not like to enter data because they are just guys who are uh, more social in nature. They just want to talk. They don't want to work on system. So actually, a lot of agents are coming which are entering data on their behalf. So that is one way the data quality will improve in marketing. Now, marketing, if they have a lot of sales data, they can work on that data, analyze that data, and change the message. But if marketers do not have any data from sales, let's say sales might say that my green t-shirts are selling a lot, and then marketer can maybe run a campaign talking about that this is the season of green, and they might get more people into your store. So that is why data quality is important for marketers. So some of these agents are filling data on behalf of sales guys. Uh, Second thing is that there are a lot of spelling mistakes. Uh, there are silly mistakes in the data. There are blank values in data where there is no data filled. So Gen AI is able to correct all of these. So for example, we worked on a system where the list of countries was coming from two different systems, and they were not using exactly uh, the same country name or the city names. So, for example, somebody might write Delhi, somebody might write New Delhi, uh, and then now the system should not understand these two things as a two different cities. It has to always normalize to one city, or he might say that in Delhi, right? So all these variations are possible while somebody is entering data. Uh, Now this data can be cleaned by Gen AI. So you will give a prompt to Gen AI that I am going to give you list of city names. but you will have to normalize only from this list of 200 cities. You have to match to the best possible match. And I think Gen AI does a very good job with this task. So if it sees N Delhi, it will change it to New Delhi. If it sees Delhi, it will change it to New Delhi. So that way you have a very clean data set. Uh, so that is one example where it can help with a lot of data quality issues. Another thing is so data privacy. So for example, one of the things is that sometimes the customers can type sensitive information, some of the chat fields. Let's say there was a form in which there was a field, and then customer gave their social security number in that field. Now, Gen AI can actually run very well a pipeline that whether this field contains any sensitive data or not. And it can mask that those data while viewing it on screen. So let's say the data got entered, but it will not show it to the agent. It will mask. So the OpenAI agent is able to figure out that what is sensitive data here, and it can mask it by default. So those are the data privacy related things. I'm sure that this itself is a huge area that can be talked about, but in the interest of time, I am going to be just talking in brief about these topics. As I talked earlier, that analytics is a very complex field. And I think one of the things that we saw that the first the analytics came, which was more of a descriptive analytics. Then came the so descriptive analytics only used to tell what is data. Then came the prescriptive analytics, which used to not only tell what is the data, but it used to tell what you could do with it. So there was a prescription given. Uh, then came the predictive analytics. So predictive analytics is based on the trends, what can happen in future, and it is going to tell you that what you could do about it, right? So, so last few years, so the predictive analytics around 2014 till now, I think predictive analytics has been a huge thing in marketing, where it is going to tell about what can happen in future or what action you should take now. So with the Gen AI, I think people are using it uh, very much, and the machine is like it does not sleep or its attention does not divert. So, for example, it can keep reading the data stream, and it can tell you about some of the anonymous patterns. So you can define rules in just English, and you can say that whenever something unusual happens, please notify me, and you can give him some sort of unusual things. For example, if from the bank account suddenly more than is withdrawn, then it is anomaly. Now, once you teach a model, then it will keep on watching those things. Uh, I think it is getting used in insurance a lot. Some of these Gen AI agents, where they are giving them the rules of insurance that any insurance guy need to follow, and the agent will run all the data on the form, and then it will tell you. So some of these things have been there, like the analytics and real-time analytics was there, but with Gen AI coming, it has added so much edge to it, that it is getting very, very useful. Uh, so the last topic that is changing marketing is the virtual brand experiences and synthetic media. So I think you might have heard about AR, VR. So some of the things, for example, one of the app for a lipstick was there, and if you could see your selfie there, it will automatically put that lipstick on you, and you can choose the shades. So that is a virtual experience, right? The lipstick is not in the real, it is in the virtual world. So some of these experiences are getting created through generative AI. And these are getting very powerful in marketing. So the brand that which launched that app had a huge publicity because a lot of women downloaded that app and tried uh, those experiences, the virtual experiences. So I think some of the retailers, they are giving features like you can try uh, a dress, how does it look like on you. Again, it is using generative AI that they will generate an image of that cloth and your photo, and it will be so real that it will feel like you are wearing that cloth. So again, some of these experiences are getting possible through the generative AI. So I think uh, at this point, since the launch of DeepSeek, we are seeing a huge amount of activity in the agentic area, and I think that things are changing very fast. So I think a lot of things are going to change in next 2 years. Lot has changed in last 2 years, but it is going to change much more in next 2 years, and it will be becoming very difficult to see that what is real and what is unreal. So that's about the Gen AI in marketing, and that concludes my presentation. Uh, I think we have still 2 to 3 minutes for any questions.
Thank you so much, sir. I request participants to ask the question. If you have any query, you may drop your question in the chat box.
If you have any question, you can raise your hand also.
So one more thing that I would suggest that you guys should use the AI itself to learn about AI, and with the new agents, it is going to get very interesting where you can create agents using agents. So I think it is more about you going and trying things out more than anything else. So now the knowledge is not the barrier. You should just be able to try things out. Okay, so thanks a
Sure,
lot
sir.
for
So now,
participation and
Divyesh, एक मिनट रुको.
your kind words. So thanks a lot, and I hope you're having a good time in this program organized by
Thank
the
you.
NIT. Thank
अच्छा,
you.
Divyesh, there is one question from my side. If some students want to do work in the in this related field, so what are the small problems for them so that they can explore as their project part?
I think you could connect them to me. I can suggest uh, some assignments or uh, like POCs or experimentation, so that can help both the company and them, so they can learn a lot and company can experiment on those things.
Okay, so it will be good because And it is for other participants also. So if they wanted to do some related area work, then they can contact with him. So one participant is asking, please tell me about the reliability of AI in marketing.
Yeah, so I think yeah, one thing that hallucinations are there, and um, the agents like sometimes they might go into a loop, but they're getting very much better over time. And actually, that is the most amount of work goes in an agent uh, to remove the hallucination and have consistent output. For example, this Lumo agent we created in just 3 4 months. This whole pipeline of collecting data from here and there and doing this. But since then, we have been working on making sure that writing tests so that it does not hallucinate, verifying its output. So, yeah, I think my advice will be that whenever you are also asking questions of agents, always verify the output. Uh, but yeah, I think using agents itself to the verify the output is possible, and that is where we are creating systems which are creating reliable output most of the time. So they'll be like 98% uh, correct, while let's say chat gpt might do 10% error rate, while we combine multiple systems and create systems which are doing very less percentage of error. And one more thing, that marketing is not a very sensitive area, that even if you don't do very big mistakes, everything is fine, right? Because it's more about communication. It is not like a hospitals, right? If you do diagnosis and it is wrong, then the patient's life is in danger. But so that's why you will see a lot of application of agents in the low risk areas first, and marketing is one of the lowest low risk areas.
So I hope there is no more questions now. There is one more question. Dipesh, can you read it? That last
Yeah.
one.
So how does the environment affect agents? So um, I don't know whether it is the environment related to our Earth environment, or is it environment for the agents. So again, environment for the agent is the thing that which can provide them sensing information. So for example, marketing agents, they can send an email and they can see that whether it was read or not. So that is part of their environment, right? What things they can observe. So getting the information back to agent is what provide them the environment, and based on that environment it learns. So definitely the environment impacts the agent if it is the agent related environment. But yeah, I'm not sure about connection between the agent and Earth environment. So
Yes.
another question is that what are the different platforms and frameworks we can use for Gen AI in marketing? So there are a lot of agentic frameworks are there, and there are platforms. So difference between a framework and platform: frameworks gives you just components that you can use it to create your own solution. The platform comes with certain facilities which are already baked in, and then over that you need to create your own things. So platform comes with some functionality already built in, while framework are just uh, a raw material that you can reuse so that you can build a system fast. So there are frameworks like Crew AI, AutoGen, if LangChain. So these are the framework. Um, Crew AI, LangGraph actually is a better environment. Uh, AutoGen. So these are some of the frameworks for this. Uh, then there are platforms. So there are platforms like Salesforce is a one platform for agent. There is another one, Lizer. So platform provides many more functionalities, and it already works to the certain extent. You can extend the platform. You can add more things to platform. So there are AI STR platforms. There are AI. So there is a relevance, and so many other platforms are also coming because uh, this whole agent space is very hot. So HubSpot is also another platform which is developing the agents. We have agent.ai. Uh, okay.
Okay, so I think there is no more questions, so we can conclude. So, Pinky, please conclude the session.
Okay, okay, sir. So thank you so much, Mr. Divyesh Dixit, for that insightful and engaging session. I'm sure our participants have gained valuable knowledge from your expertise. Also, a sincere thank you to all the participants for joining this online session, for your active engagement, and for making this discussion lively and insightful. We hope you found this session beneficial and look forward to your participation in upcoming sessions of this ATAL FDP. Stay connected, keep learning, and see you all in the next session. Thank you, sir.
So I'm dropping my LinkedIn profile in case people want to connect with me and they want to message me, then they could send. If you have any other questions, you could ask me, or if you want to contact me also for uh, if you, in case you are interested to work on a project, so could contact me there.
Sure, sir.
Thank you.
Okay.
Thank you, sir.
So thank you, Divyesh, for your nice presentation. And I think it was very much informative and liked by the participants also. And thank you for giving time for us.
Yeah, and thank you, Anurag, for coordinating this event. And it was a pleasure speaking to all the audience and you. So thank you, Pinky and Anurag.
Okay.
Thank you.
Thank you, sir.
Bye.
Bye. Okay, participant, thank you for attending this presentation for today and for your patience, for your learning. So now you may leave the presentation. Okay, good night.
Participants, please, you may leave the meeting so that we can take the attendance at the last.